Yo, what's up, guys? So today I will make an, another like handwritten digit recognition model, but this time it will be a lot better. We can save the model so we don't really retrain the model every time. We will make the syntax simpler. Actually, I might still make it like the one we used before since uh this is more of a beginner, like a video that's more toward beginners. So I would not really use any very hard function in this case. And alright, I will just show you guys some example. Let's say this is a 5. What will the uh, model think it is? I hope it's a 5. I mean, if it if it give me some random stuff, it'll be kind of embarrassing. Alright, it did give us a 5. And now uh, let's say a 2. Oh shoot, I forgot to save the file. Yeah, it will give us a 2, which is quite nice. So, yeah, let's just jump into the code. So, MNIST. I mean, if you saw my previous video already, you can just skip to the part that you like to watch. MNIST equal to fetch OpenML. So, MNIST 784 version equal to 1 and parser equal to auto, and we'll just make x, which is our image, equal to MNIST data. Well, y will equal to MNIST target. So x will be the pixel value, the gray value of each pixel. So let me print x. Yeah, so in this case, pretty sure 0 is white. Let me search it up. It's 0, white, or black. Okay, it's black. So this is, all of these are like blacks. And then there are like white here. So the x would be just the gray value for each pixel, which range from 0 to 255. And there's 70,000 uh, rows, which means there's 70,000 images that have 784 pixels. So each image is a 28 by 28 image that have a gray value associated with each. And yeah, so let's just x equal to x dot values. Oh, I forgot to print y. Okay, so yeah, y will be like the digit of the image. So like each image will have a digit on it, maybe like 0, 5, or etc. And our target will give us what is that number. So first, I will just show you guys what is some of the digit with Matplotlib to just visualize it a bit. So let's just, for I in range 10. So I'll just show you guys the first 10 images, and image will equal to xi image that reshape. So we'll reshape it into a 2D array in the format by 28 times 28, since this is how it should look like. And then plt dot image show image and plt dot show. So this will just show us the image. And let me just wait a bit. Yeah, so you guys can see there's a 5, and then it's a 0. That's an awkward 4. Okay, but I don't even understand what digit is this. I think it is supposed to be a 1, but a really bad one. Okay, a 9, a 2, and a 1. This is a better one, a lot better. A 3, another 1. This should be a 4, but it looks like an H. And yeah, these are the 10 examples. So now we'll modify the value so that we will change all the 0 pixels, just make them still 0. And in this case, 0 will be white, while 1 will be black. So we'll change everything that's not 0 into 1, aka black, since this will make it will make it easier for the model to comprehend. So x equal to np.where x is greater than 0, then x will equal to 1, otherwise it will equal to 0. Okay, and then let's just do I need to add a one? Oh yeah, a comma here, and then now we can print x. So now the x will look like an array from 0 or 1, which is a lot better compared to this one, since we don't really need all the index label or the pixel label, but we just want it to be a 2D array to give into our model. So this is just a very useful NumPy small function that will just access all the x, and if it is greater than 0, we'll make it become 1. Otherwise, it will be 0, which is quite nice. And okay, also forgot to mention, but these are the libraries that we will use. Print x, and then y will just equal to, pretty sure y dot us type int. Is this how to declare it? I kind of forgot, but it's alright, it's alright. I can just use y dot values. Yeah, so this is another NumPy small function that would just change the y, which looked like this before, into a very simple array, which is a lot more easy to just for the model to understand, since and this one is not so good, I would say. And now we just get our function, which this time it'll be a neural network, which is known as MLP classifier. I suppose it will have a better accuracy than the one I did before, since k nearest neighbors, I will not say it's that good. So model will equal to MLP classifier. It doesn't need any argument, and then model dot predict. Oh wait, sorry. Model dot fit x and y. Quick and simple. So now, what we will do is there's a very mm, interesting function. It's called joblib.dump. So what we did in this case is we trained the data and modified it so that our model can like understand each value. However, the thing is, we don't really want to retrain the data every time when we're like trying to use it to predict a digit. So we'll save this model. So the name of the model, obviously, and then we'll save it as model.plk, I believe. And yeah, we'll just run the code and we'll save it. This is how you will save this model. So you don't really need to train it every time as you use it. Which the code is just a lot more simpler since in this video we only use 23 lines of code, which is quite nice. I actually don't really need these. Unlike the one I did before, I'm pretty sure I used 30 lines of code or something. And did it finish? I just need to wait for a few moments. And while I'm waiting, I'll just say, if there's any error in what I said, feel free to point it out. And please subscribe, just if you like this video. Yeah. Why is it spinning so long? While waiting for it, I would just like put these codes here. Oh shoot, is it PKL? Okay, it might be, alright, that might be my fault. I mean, actually, I already have a model, so it would be called model digit, that PKL. Oh, I think, let me just pause this. Okay, so let's just run the code. This time it should work. It basically just save the model and yeah. Cause I already had one before. Like I already saved the model in the model.pkl. So this time I will save it as model underscore digit.pkl. And I misspelled in the previous line of code. If you're feeling very sorry, it's PKL, not PLK. And I think we just need to wait for it to just process everything. I hope. You can skip this part. While waiting, I'll just talk about these a little bit. So you will see that in our code, we didn't really use so much lines of code on the model itself, but we used more of it on like just dealing with all the data and stuff. So this is cause a large portion of machine learning it's about data. Though model is also very important, but usually people already like done a lot of stuff about the model, and they already like helped us mm, very conveniently use the model. Oh my god, why is this thing spinning so long? Okay, now it's finished. So I'll just simply put the code here. And then let me delete these. So now we can access the model like this. Model equal to model. Pretty sure it's called joblib. Oops, sorry. Joblib dot load. Oops. Model digit dot pkl. Let me see if it works. I hope it do. Yep, it do works. So now what we will do is we're going to get our image, obviously. So it will be like this. Image will equal to image dot open. Uh, so we used this library, a very convenient like library to deal with other images and stuff. Wait, sorry. Let me just open this to see what is the name of my file, cause I forgot. And then here, and then we'll convert it into a gray value. So, cause like now when we do plt dot show plt dot m show image plt dot show. So now what will happen is that it will be converted into a gray value, because before it's without this it's actually not really a gray value. It's what we drew here. So if we drew it in like, let's say red, say we drew a 4 in red like this, right? Let me save the file. It'll print out a 4 drawn in red. However, if we just convert it into gray value like this, no matter what, it will give us a string. I mean, not string, sorry. A single number from 0 to 255. So, but like a matplotlib will show it as yellow to purple, which is because that's how matplotlib do it, but it should be a black and white image. So what we will do is we'll print image. Wait, actually, pixel will equal to image dot, np dot array image. So what this does, it's just I will change it into a array. Since we already know that everything is made out of a huge like every image is made by each pixel, and each pixel have like value and values associated with it. So without this convert L, it will look like this. A lot more like uh longer. So since it will be each value, it will have a RGB and a transparency to it. But if we just convert it into like a gray value, there will not be this mm, eh, like RGB and transparency. It will just be one number, which will make it very easy for our computer to just interpret and for a model to just like predict the data. And what we'll do is we'll just do what we did before, a for loop, accessing for I in pixel, and then for j in I. So we'll also create a list, pixel list. Currently it's an empty list. And then if j equal to, if it's like 255, then we will add. So currently 0 is white. So we'll just add 0 pixel list dot append 0. Otherwise, pixel list will just append 1. And then ARR will just np.array pixel. So basically what we've done is we used a nested loop to access each of this pixel value. And if it's 255, which if it's white, we'll add white like 0 to our list. If it's not white, like if it's any other color beside the background, we'll add 1, currently black. And then we'll change this to an NP array, and then AR equal to AR.reshape. Oops. What the frick? Reshape. Sorry. 1, -1 to change it to a 2D array. So what this will do is that it'll make it simpler for our model to interpret, because otherwise, if we just make it to a gray value like this, it will be a lot, it will take down the accuracy by quite a lot, since we don't really need to care about other like 253 since the number is just a number. And yeah, let's just say print model dot predict ARR. Let's see what it will give us. Oh shoot, I forgot to do the convert L. Then change it back. Okay, this is my fault. Yeah, so it will give us a 5. Bad guess. But currently we still didn't really finish. So usually, alright, so just go here, search up paint, and then open paint. Usually your image will be something like it will start with image something like this, which is not 28 by 28. So what you do is go here and then press pixels, make this become white just by clicking on it, and then change this to 28 by 28. Okay, and then scroll in, like zoom in. If you're on a PC, just like control and move your mouse. So let's just write a random number. Let's say 3. Save your file, like it can be anything, and then just change this to your file, this link, and then now let the model just predict. What the frick? It predicted this as a DRL, which is not so good. And also, every color do indeed work. Beside white, though, beside white. So you can use a 7 as an example. Since we will always convert the image to a gray value. Oh shoot, I forgot to save the image. And just remember to save the image after you modified the number inside. Give us a 5, which is wrong. But yeah. And basically that is it. Bye.